Good morning, everybody. This lecture is going to be over general safety. I got a question for you. If you had to describe or define safety, how would you do it? What is safety?
Common sense.
A lot of it's common sense. Okay, I'm going to tell you, I don't really know how you would describe safety. But, I have to go to Mr. Webster to see what he said. But I'll tell you, I know one thing. If I don't have a plan of action, there's no way in the world I can be working safely. Any of you play pool?
Doing a job without getting hurt or damaging something?
Are you good at pool?
Not really.
Oh, come on. Now, I'm trying to figure out who not to play against in this pool thing. But this is the reason I ask you if you play pool. If you've ever played a game of pool, you know that you're not going to stay at the table if you're just taking random shots. You have to have a plan. You have to know if you hit the cue ball in this direction, what's going to happen or what do you expect to happen. So that's safety. If I have a button on a piece of equipment and I don't know what that button does or what's going to happen if I mash that button, there's no way in the world I'm going to be operating safety there. Okay? So we have to think of that away. Now, who do we, why do we want to be safe? Well, number one, we're worried about ourselves and others. If we're doing something that may injure ourselves, we definitely don't want to do it. If we're doing something that may injure somebody else, same thing again. We have to think about ourselves and others. Have a game plan. All right, one of the game plans is what if you do get hurt or somebody around you gets hurt? Do you know first aid? Do you know what to do in case somebody gets something in their eye or a finger cut or electrocuted? Or, do you know what to do? Well, goes back to having that plan. You need to have a plan. In a shop or even in a work environment of any place, in the field, doesn't matter what, you need to have a plan of action. Here we have a plan of action in case of a fire. We know that we're supposed to exit certain places and go to assemble in certain places. In case of bad weather, tornado warning, we know that we're supposed to go to a certain place. That's the idea of safety. That's what we're all about. Okay, that's one area is personnel. Another area, in fact, I have 6 areas that I'm going to point out. Another area is the equipment that you're working on. If you come up on a piece of equipment and the wires are frayed on it, and you see some valves that have been, looks like they've been hammered on, things like that, I want to assess that piece of equipment before I start working on it. Okay? I don't want to go plug something up that half the wires are showing on. We got to be safe about it. And let me say this about that. Not only do you look at the equipment, you also need to know where any disconnects or isolation valves may be before you get started. Not after you get started. If you turn this thing on and all of a sudden sparks going everywhere and you need to go figure out where the main disconnect is for it, it's too late. Okay? Like I said, you need to know what's going to happen before you execute. What about our tools? Now I'm going to be pointing out more about ladders in a little while, but ladders, we put a lot of emphasis on ladder safety. Many accidents happen with people working on ladders, not just from falls, but also using the wrong type of ladder or the wrong type of rated ladder for the job. Make sure you got the right kind of ladder for the job. Make sure it's in good shape, and we'll be talking more about that as we go on. Hand tools. If you got a wore out piece of pliers, and I'm going to say a piece of pliers because that's seems to be what pliers usually are, but if they're wore out and they slip half the time, you need to throw them things away and get you some good tools. Okay? If the tools are not in good condition, for example, if you got electrical pliers and half of the insulation is gone off the electrical pliers, you don't need to be doing electrical work with them at all. Power tools. We have battery operated tools nowadays and electrically ones that still plug in. Make sure that they're in good shape. Again, if you have a frayed wire on there or a switch that's sticking, you're asking for trouble. That's all it is to it. You're asking for trouble. And don't forget about mechanical tools too. Now you say, what in the world do you mean by a mechanical tool? Let's say that I've got a pipe and die set, for example, and I've noticed that my die may be partially cracked. It's time to throw that thing away and get something new, okay? Meters. Probably one of the biggest things that I have seen people do with meters is not pay attention to the shape of the leads of the meters. If you have a lead that sometimes it works, sometimes it doesn't, let me ask you this. Are you going to trust that thing enough to be able to touch a circuit? Okay, I don't want to. In fact, every time I get ready to use an electrical meter, I want to go to a known source and make sure that meter works correctly before I trust it at all. Okay? So keep that in mind. Make sure that your readings of your electrical meters are reliable. You know, make sure that they're rated for the right voltage and the right whatever you're working with. If you got something that is rated for only 250 volts and you're working on a 480 volt system, you're bound to get hurt. Okay? Make sure that they're the proper ones. Gauges and other meters, make sure that you have good hoses. You don't want a hose busting on you. You may have 400 or 500 pounds of pressure on that hose. And you can only imagine what can happen from that in case of a hose bust. Make sure they're accurate. When I say that, let's say that you got something that is telling you that you've got maybe 100 pounds of pressure when really it's 150. That may get you in trouble. So make sure that they're accurate. And they do wear out. Tubes do wear out.
You don't want to be that guy.
So you'll find out that you'll constantly be buying tools as you go through this this particular career. It never ends. Plus, we like the best that there is out there too, in a roundabout way. You know, if there's a new gadget that comes out, we got to have one. Is that right? I always like to wait till the price drops a little bit, though. All right. What about another area? Chemicals. You may say, "Well, I'm not going to be working with no chemicals." Yes, you are. Refrigerants, cleaning agents, oils, all those things fall into this particular category. Everything that is considered as a chemical has a MSDS sheet to it. Y'all know what an MSDS sheet is? Okay.
Yes.
What do you find on the MSDS sheet? You find out what it's actually made of, how it's, or I shouldn't say how it's made, but what the components of it are. You find out that there are safety procedures in case of spills or in case that you may have breathing. Help me out there a little bit, Ricky. It's going to tell you what to do in case of accidents too. Okay? First aid also, it'll tell you how to handle that. You need to know the product that you're using. Okay? Refrigerants is a good example. Refrigerants can be, in some cases, they can be flammable. They may actually be toxic. And one thing's for sure, most refrigerants you can get burned from frostbite, if you will. And I don't know if you're familiar with a coal burn, but a coal burn is just as bad as if you were burnt by fire. We don't like to talk about things bad that happen, but I have seen more than one person wind up with blisters on their hands where they weren't wearing the proper PPE and had a refrigerant hose or something not come loose correctly, and they tried to continue to get that hose loose with the refrigerant running between their fingers. R22 is a good example. R22 boils when it hits the atmosphere at approximately minus 44 degrees. Now, that's going to burn you, and you'll wind up with injuries just like you stuck your hand in a fire. We don't want that to happen. Lord help us if that were to get into the eyes. You can imagine. So keep in mind that you're going to be working with those type of things. Be safe with them. Let's touch a little about electrical safety. Have you ever seen somebody work something hot? You know what? In this field, you're going to be working on a lot of things with the power on. You cannot troubleshoot most systems with the power off. It has to be on. So what do you usually hear someone say when you say electrical? They say, make sure to turn it off. We can't do that. We got to have it running. We got to, or have it trying to run. So we're going to have to do our electrical checks and our troubleshooting with the system on. So you're going to be working with live voltages. Well, how do you do that and still be safe? First of all, respect it, but don't be scared of it. Now, let me scare you, since I said that. It takes less than a half an amp to kill you. Current flow. 50 milliamps can cause death. Okay? Now, you say, well, I know some of these systems have 24 volts. That's not something to be real worried about. Well, I tell you, 30 volts can generate 30 milliamperes on an average body. Now, that may not be lethal, but you ever thought that maybe it might make you jerk into something that would be lethal? Okay, I'll give you an example. If I'm working on an electrical panel, and let's say this electrical panel is right here, okay, a lot of times there will be someone with me, an assistant, if you will. I'm going to turn my back to you for just a minute because I want you to think that you're behind me. I'm working with this electrical panel. It's live, okay? It's live. You're standing right here. I come over here and all of a sudden I grab something that's hot and it comes through me. Your body is going to have your muscles to contract. If you're standing right behind me and this thing causes me to get electrocuted, I'm going to jerk back. There's a good chance if I got a screwdriver in my hand, I may actually jerk back that way. Uh-oh. Somebody got hurt, didn't they? It may have not been me, but it was that person behind me. If you touch someone that's getting electrocuted, you're going to get electrocuted too. So if you come across somebody who is in the process of being electrocuted, don't touch them. Cut the power off to them. If you can't cut the power off, knock them off of there with something that is non-conductive. Okay? The sooner that you get them loose from it, the better chances they have of surviving. Are y'all familiar with what's called lockout, tagout?
Yes.
Okay. Okay. Lockout, tagout is where you actually lock the circuit out when you're working on it. You actually have the key yourself to the lock. Only you can unlock it. You don't hand that key to somebody else. Okay, nobody else is supposed to ever unlock it. You tag it out. Your name would be on that tag saying that you are the one to see to cut it back on. That way, in case you're working on something that's on the other side of the building that could be turned on this side of the building, somebody doesn't come up and flip the switch while you got your hands in. It's part of safety. Okay, another area that I think we sometimes take for granted is fire prevention. You know, you'll hear this come up again, especially in our brazing and soldering lab. But if you're dealing with hot materials, then you need to have the fire prevention or fire extinguishers or whatever you're going to have to use to put a fire out in case it catches up. You say, well, I'm just going to have this little thing on here for just a minute or two. I just got this one little soldering to do. I'm not going to my truck out there and get the fire extinguisher. Don't think that way. I had a friend who was doing an install on a house. The people were on vacation. He had a can of PVC glue and cleaner that was in the room with him, not where he was at, but the fumes flashed over and it burnt the house down. All he could do was sit back and watch, and these people were on vacation. Luckily, it didn't hurt him. He tried everything he could to do